Alright, so you say the diagram below, not drawn to scale, shows a relative position of three reservoirs, B, F, so here's B, F, and G, on a level ground. The distance BF, which is this, equal 32, FG, which is this, 55. Angle BFG is 103, and then say, determine the bearing of of B from F. So what happened? You see where the from is? That's where the bearing is gonna be. So it's gonna be at F. So all we have to do, draw a bearing line, or a north line rather. So what happened, guys? You see this angle here and this angle here, they're supplementary. So this angle plus this angle add up to 180. So to find this one, we just subtract 42. Forget the angle right here. 2 from that we can't, so we borrow. 2 from 10 leave 8. 4 from that leave 3. So this angle here is 138. And the significance of that is, once we know this angle here, 138. Once you know this angle, how bearing work is measured from the north line in a clockwise direction. So we are going to go from the north line, which I'm going to use in red, go all the way to here. That's going to be the bearing, the angle here. So it's going to include the 103, but it's going to exclude the 130. 138. So all we have to do now, the entire thing is 360 degrees, right? So it's 360 minus 138. That would give you the balance. Agree? 8 from that we can't. So we for 5. 8 from that leave 2. 3 from 5 leave 2. So the bearing would have been the angle from here include this. So all of that would have been 222 degrees. So that would be our bearing, and that's 1 mark. So just remember, this angle right here and this one is supplementary. So once you have that, normally you can figure it out from there. All right. In terms of BG, the length BG, that should be very easy, right? Because look at it, guys. We have this angle that is 32, that side rather, and we have this which is 55, and we have the angle. When we have a known angle, well, a angle between two known sides, what we use, cosine rule, right? We have that as notes, so you can review it. That's when we use the cosine rule, when the angle is sandwiched by two sides. So the cosine rule, it would be 32 square plus 55 square minus 2 times 32 times 55 cos the angle, which is 103. So remember, inside angle we are using, not the bearing, right? So cos 103 degrees. All right, I'm just punching in on my calculator. You guys can work it out as well. So if I made any error, you guys can point it out. So this give me 1024, 55 square. That's 3025. Remember, drop a big bracket around this, right? So I'm going to work out that part. 2 times 32 times 55. That's a 352. 3520 times cos 103. It's going to be a negative angle, you know. Let me try it. All right, yeah. So minus 0.224 9510543. All right, so we work out this part first. So it will be negative that times 3520. So this part now work out to, you guys can check, tell me if you get it, 791, call it 0.83, right? Round it up. It's negative, so it's gonna be two negatives. And then we add this, which is the 1024 plus 3025. All right, my calculator gave me 4049. So this is gonna basically add. So let me just add that, and then we find the square root, and that should give us the length of that side. Plus 791.82. All right, so it gives me this, which is 4840.83. And now we have to find the square root. So what's the square root of 4840.83? All right, so it gives me 69.576. Let me see what then they say if we round it up. To one decimal place. So it's not the nearest tenth, one decimal place. All right, so if a one decimal place, this would work out to 69.6 kilometer. That's the length of BG. So we could just use the cosine rule to find the length in terms of the bearing. I show you guys that already. I have a tutorial coming up. We're gonna do that in one of the 2-hour class. All right, so that's that.
Sir.
Yeah, man, go ahead.
Good night. What tutorial you have coming up, sir, for measurement?
No, it's on bearings itself.
Oh, okay.
Yeah, because I did that a workshop with that at a school. I will just show you guys how we can use a 2-hour.
Oh, yeah.
I hear
Please
you
do,
show up
sir.
about your workshop. Nothing.
Oh. Yeah,
Sir,
man.
please do.
No, man, it was a great workshop. I really enjoyed it. The
But who
kids
show
enjoyed
off?
it. I'm not sure if somebody asked me about it.
But who show off, man? Hold on, sir. Let me screenshot it. Go back down, please.
Yeah, man, I'm gonna go back up. The next one say, calculate the nearest degree, the bearing of G from B. Remember, guys, the bearing of G from B, the bearing, and it's to the nearest degree. I'll go back up there. So it's the bearing of G from B, the bearing of G from B. Don't want to forget it.
Back up a little more, sir. Or zoom in, zoom in, or zoom out, or something. That I can see all of it. Right, you can go now, huh?
All right, guys. So I want you guys to try that one. The bearing of G from B. I hope I got that correct. The bearing of G from B. So, so from B. So I hear so the bearing are gonna be right. Try it, guys, and then we can see how it works. And it's to the nearest. I don't remember. To the nearest something. But we can always
So
go back.
you can scroll. You can scroll.
All right. All right. So they want the bearing of G from B. Notice at the from it will be right. So they want this bearing. Remember, all bearing work, we start from the north line, go to the line in a clockwise direction. So we need to figure out this piece here, because we already know so this is a 42. Even though, technically, bearing a right, so you know, your right bearing a 042. It's supposed to be 3 digits. I don't know how CXC just fling down 42 this one. But it's supposed to be 3 digits. Alright. So that's how it works. One, this angle here. We could use the sine rule to get this, you know, or the cosine rule as well. Because since we know the sides, we could use it. But I think I'm going to use the sine rule to get it. Alright, how the sine rule works is the opposite angle. We could call this theta. It's the opposite side. We already have the 103 and we have the 69, right? So we can work with that. So it's the opposite side, we must to the opposite angle. Space limited. So I'm go down some. So basically, we start with the angle. So it will be 55 over sine theta equal to the 69.6 over sine 103. Alright. So we can cross multiply as well, term you guys like. Sine theta times 69.96 is equal to 55 times 103. And then of course we divide by the 69.6 because you want to get sine theta by itself. So sin theta. Alright, I could work out this. Akila, the way you do it, I'm gonna just copy your number then instead of your use calculator. So that'll be 55. So what is sin 103 then? Alright, so 55, hold on guys, 55 times sin 103. Alright, this work out to 53. The top work out to 53.59. We're going to divide that by 69.6. So let me divide that. So 53.59 divided by 69.6. That give me 0.769971264. Alright, the more number you use, guys, and the more accurate it will be. Alright, so that's why I do that. So what we do now, we press shift sin, and you're gonna see this come on your calculator. I want you guys to do it as well. And you write down the number 0.76. No, it's supposed to be 6. Well, and then when I press equal, it will give you the 2, 6, 4. Alright, so I'm gonna do that. So shift, so 0.769971264. Alright. So this give me 50.35. Now they did say to the nearest one. To the nearest, let me go back down there. To the nearest. Oh, to the nearest degree. Alright, cool. So that'll be 50. But that's not the answer, right? Because we're looking for the angle, this angle here from right round here, so right round. So it should be 42 plus the 50. So that'll give me 92. The bearing, it'll be 42 plus 50. 92. And it almost look like 90 for true, watch. 90 no go so. It almost look like 90 for true. Almost. So that would have been 92. So guys, you can use the sine rule to find angles and you can use it to find the side. Could I use the cosine rule as well? So it depends on which one you're more comfortable with. Where you can transpose the same formula we use find length to find the angle. All you do when you divide, you press shift and then whatever decimal you get. And these take up a lot of time, These take up a lot of time because I don't know why 6 have to use them big number here. Look at 32. Them could I use 8 and 9 and those little numbers. Yeah, that is true, Ramon. When it's non-right angle, that's when we use. Alright, if it's a right angle now, we use a trig ratio and so. Be a foolish is me so much. Alright, let's go on, because I know this is not a fun topic for you guys. Oh my. This is everybody's favorite, right? All right, let's try this one, guys. It said the diagram not drawn to scale shows a circle with center O. The points A, B, C, and M are on the circumference. The straight line CN is a tangent. So CN, that's a tangent to the circle at the point C is perpendicular to BN. So that means 90 degrees, right? And it said, determine, given reason for your answer, ABC. Find ABC. Pause the video, because this might take some time. I think there's 2 more. All right, so I could find them. The number 10. With circle theorem, guys, is just how you see them. You see BMC first, put it in. I'm not going to reason it though. I think ABC is very easy to find. The fact that they have this being the center and the line drawn through the center, that means that it's a one diameter. I think this is the key for this part. So if it's a diameter, that means the angle would have been 90, which is this angle right here. If you look on a rule in your book, you literally have this one. Barring them, you have to just block out them here sometime. But this one would have been 90 degrees. So that made this very easy to find, because if we know so this is 90 and this is 58, we can say this plus this must give a 90, right? Because this one is already 90. I was actually doing this with PEP students, angles in a triangle today. So basically, 58 plus the angle must give a 90. So all we have to do is subtract 58. All right, you want 2 more to make 60. So that will be 32 degrees. So right here would have been 32. Once you start seeing now, it's supposed to get a little bit easier, right? All right, we'll see if we can find MCN. MCN, so that's a MCN. I could find that one here first. All right, so I could find, so BMC, yeah, I could find that one here first. BMC now, if you look at it closely, you can see it's a cyclic. Remember we talked about that, right? Once it has 4 sides and all 4 vertex or vertices is sitting on the circumference of the circle, it's a cyclic. What do we know about cyclic? The opposite sides add up to what? 180. So the fact that this is 58 we know say that angle here, call it A. We know say angle A plus the 58 equal 180 degrees because them supplementary. Oh, you can put that reason. What was the reason for this again? It could be angles in a triangle add up to 180, right? For that one here. Because that it come down to. Alright, for this one now, cyclic quadrilateral, or you can say supplementary, right? So this will be A is equal to 180 minus 58. That will work out to 122. So we have two at the angle. That wasn't so bad, guys. But we have to look. Tough, you know. You have to figure them out. So this will be 122 degrees. Alright, look how easy it get now. We need to find this angle. Readily, we know say all of these are probably 58, but see that it split. It split. So we could just ignore that rule there. If we meds it deeply, this one is angles on a straight line. So if that we know say this are 90, that draw me interest, the 90 here, right? So if we can figure out that angle here, we can figure out this quite easy. Angles on a straight line add up to 180, right? So what we know that forget that angle here, we could call it x. It'll just be 180 minus the 22, 122, which give you the 58, right? So right here are 58. And of course, this is 58, yeah. So the 90 plus the 58, come back to the same thing. So 32. Somebody check it if everything go right. So this are 32.
In 90 plus the 58, sir.
Mm-hmm. That's
148.
at 22. No, this are 22, you know, this are not 32.
58.
Hmm? I think this are
90 plus
22 though. Because 2 carried to 60. Oh yeah, 32, 32. You're right. 2 carried to 60, 30, yeah. Alright. So this would have been 32 for that angle here. As technically, you know, the 58 become like a two identical triangle now that me I made it. The 58 plus the 90, I same thing we have here, so 58, 90, 32. So is that the triangle here identical to this one? In terms of the see there, 90, 58, 32. But this is one cyclic. So that's why we get the 122. And then this now angles on a straight line up to 180. So two reasons, angles on a straight line, plus the fact that you have angles in a triangle add up to 180. That's a total of 5 marks. Yeah, or 6 marks. Alright, cool. Alright, here's a vector, guys. The diagram below, not drawn to scale, shows a quadrilateral ABCD in which AB equal M, DC equal 3M, AD equal N. L is the midpoint of DC. Complete the statement below on the geometric properties of the following vectors. AB and DC are what the and for? Oh, it a continue. Yeah, AB and DC are blank and AB is blank times CD. So 2 marks or 1 mark each that, you know. I just made it, you know, Francis said. See something else something. I answer that one, guys, and then we can express BC in terms of M and N. All right. So he said the diagram below not drawn to scale shows a quadrilateral. So see, it's a quadrilateral, 4 sides, 1, 2, 3, 4. ABC in which AB is equal to M. Sometimes I wonder why they put this, but yeah, guys, they already show you. Notice the arrow, guys. Remember that important. D to C, 3M, right? And AD equal N. And L is the midpoint. I actually put in this because I don't know, I think it was missing. Think it fidelity. So L is the midpoint from D to C. As you see, it's going in that particular direction. It's a complete the statement below on the geometric properties of the following vectors. AB, so AB and DC, as you can see, that's gonna be parallel, right? And AB, notice them say AB. AB is 1/3. If it was DC, we'd have said DC is 3 times AB, right? But this one, they're saying this, as this are 3, this are 1, that means 1/3. All right, so that one was set up for kids. All right, so that one would have been 1/3 times CD. All right, them say express BC in terms of M and N. That means we're gonna have the vector from B to C. But remember, we're not gonna go directly. Alternate route, right? So we're start at B because it's from B to C. So what we're gonna do now, we're gonna see from B to C what route we're gonna take. Only one route there, right? So we're gonna go from B to A. Very important, you know, guys. A to D, all of them that important, you know. The order matters plus D to C. Notice the letters they match up like A and D. So you just show the continuation. Now AB is M. If we're going against the arrow, remember that when we're going against the arrow, it's supposed to be negative, right? So this would have been minus M, that's the size. We're going with the arrow here, you know. So plus N. And we're going with the arrow here, so 3M. Rearrange. So it will be 3M minus 1M, which is 2M plus N. So that's this vector right here, which is 2M plus N. And that is our vector. All right, as Mr. Guys, I'm putting in this. I think it was originally supposed to be there. The vector
Can you
BL
scroll
in.
back down 1 minute, please? Let me see something.
Yeah, man, I'm not finished. I'm gonna go back up. So the vector BL in terms of M and N. All right, so make it and then we can continue.
So, sir, you said 3M minus 1M, so
Did it?
M plus N.
Yeah, because remember, you know, this is minus M because you're going from B to A. You're going the opposite direction. So once you're going against the arrow, it's supposed to be negative.
You do January 2025 people already, sir?
No, I not even think me get it.
You not get it?
Me not think so.
I think a paper they are gonna come. It's gonna be mostly like close to that paper there.
CX in your work, so you know, guys, just prepare because we don't know, honestly. I've never seen them really bring on a paper. Them just have them own thing. So just no limit yourself to it, alright?
No, I'm not limiting myself, but based on what I would have looked at some point, when I'm going through some of the papers, and C.
Okay. So guys, from B to L. Yeah, man. So do we think we could get from B to L? I think I added that basically because there's no way they're gonna add in this. Look at the midpoint and they don't ask. So we just say from B to L. You guys can try that and then we go through it. So from B to L. Think the paper that I got that was missing. All right. So from B to L. I think a two route you can take, I try both routes. It's supposed to give you the same answer. All right. So from B to L. Route 1. May I take the route here? And the route here. All right. So if all of these are 3m, right? That means that this are going to be half of it. So half of it will be 3 over 2, right? We just divide it by 2. Technically, a 1.5. But vector go already. We not really. Hold on, guys, one taxi. Hold on, guys, one taxi man stop on me gate and play music. Hold on. You two always a flag me for them something. I'm just pause it till them pause. One for them. Alright. Think him gone. So we have BL. We can take the root here, which is 2m plus n. No, we're going against the arrow, right? Because see the arrow going this direction and we're going this way. That means we are going against the arrow. So this will be minus 3, 2 over m. 3, 2m, right? Which is a half of this. So we could group them. So 2m minus 3 over 2m plus n. So this will give a half m plus n. I'm going to try the other root, guys, which is, let's try the root here. Must give you the same thing. There's something wrong. So we are going to go so, and then go so. Halfway, right? So that means we're going against the arrow. So minus m plus n. And of course, it should have been plus 3 over 2m. Yeah, same thing, See them? All right, we group them. So that'll be 3 over 2. So this is a 1, right? So this is a leave half. Because this bigger. This is a 1.5. So this bigger. So this is a leave half m. And then you add the n. So any root you take, it would have been the same. Alright. So we basically did half of it. Well, let's stop here. Let me see if no more question. No. No. No, I left a big space. Alright, so next time we are start from here, so. Alright. I drop in a number 3 because I realize that this have to do with distance, speed, and time. So I drop in one of that. Alright. Let me stop the recording. So guys, take care and I'll see you guys. Somebody else